video. We have two mirrors. Among these two mirrors, the first one is concave mirror. Understood? Look at this. If an object is placed very nearer to the mirror, it is enlarged. Is there any application for that? Yes. One application is this type of mirror is used by the dentist. This type of mirror is used by dentist for getting an enlarged image of the teeth. To get the enlarged image of the teeth, this type of smaller mirror, okay, used by the dentist. So understood? All of you clear? The dentist. Any other application? Yes, definitely there are other applications also. I will discuss one by one. This application will be asked in exam. Uses of concave mirror. All of you please listen. Concave mirrors are commonly used in torches, searchlights, and vehicle headlights to get the more powerful parallel beams. You please understand, the torch or searchlight or car headlight, understood? In the car headlight, concave mirror is used. Why we are using concave mirror? I will explain. All of you please listen. Actually, that diagram is not available in our textbook. That diagram is not available in our textbook. But if you look at the headlight of the car, there is a small lamp. Understood? There is a small lamp in the headlight of the car. There is a small lamp. And in this side, there is a concave mirror. This is a rough diagram. 1 minute. There is a small mirror. There is a small lamp. This is the lamp. Okay, bulb. There is a bulb. And in the right side of the lamp, there is a mirror. Not a plain mirror. It is a concave mirror. In the right side, there is a coating. There is a coating in the right side. I am keeping this lamp in the focus. All of you please listen. Actually, this diagram is not there, but the application oriented questions are normally asked in exam. So you must understand every concept. So we have to put the lamp exactly at the focus. You still remember focus, right? This is the concave mirror. The lamp, there is a lamp, bulb. The bulb is kept exactly at the focus of the mirror, concave mirror. So you know that the light rays will be emitted from the lamp. Understood? These are the light rays emitted from the lamp. Right side there is no emission. We have an adjustment. We have such an adjustment. All the light rays moving towards the right side, it will undergo reflection. It will undergo reflection. So you know that there is a property that if the light rays emitting from the focus, after reflection, it will be going like this, parallel to the principal axis. It is simply the reverse of one rule. If a ray coming like this, we studied it as a rule. Let me explain that. After that, you can ask me doubt. If a ray coming like this, parallel, after reflection, it will be passing through focus. That is the first rule. We studied already. In the case of concave mirror, a parallel ray, after reflection, passing through the focus. The reverse thing also happens. A ray emitted from focus, after reflection, goes parallel. All the rays emitted from the focus, I have placed a lamp at the focus. All the light rays after reflection goes like this. Understood? The light will be going like this. This is the okay. So the the light rays coming like this. It can go a large distance because the parallel rays are emitted. Understood? These are the parallel rays emitted from the headlight. This is the headlight. So the car we can easily watch the distant objects, because what is the nature of this parallel beams? This parallel beam can travel a lot of distance. Understood? So we can see the distant objects using headlight of the car. All of you clear? Samruddhi?
Yes, sir.
Lina, Lina left. Lina is there. Samriddhi, have you understood? Samriddhi?
Yes, sir.
So the reflected rays goes parallelly. We get a powerful parallel beam. Understood? We get a powerful parallel beams. Using this parallel beam, we can watch the distant objects. The torch, okay, in certain torch we are using concave mirror. Understood? So that is written here. That is written here. Concave mirrors are commonly used in torches, searchlights, and vehicle headlights to get a powerful parallel beams. The parallel beam can travel a lot of distance. We can see distant objects. Okay. So the first use, have you understood? The first use of concave mirror is clear to you?
Yes,
Yes,
sir.
sir.
Nishid,
Yes, sir.
understood. Then second application, they are they are often used as the shaving mirror to see a larger image of the face. I told you, okay, if the nearby object is enlarged, understood. The shaving mirror, I have already discussed that. The concave mirror can be used as a shaving mirror. Understood. This first one is the concave mirror. If I am standing nearer to this mirror, I can see my enlarged image. Understood? I am standing nearer to this. I can see my enlarged image. So this type of mirror can be used as the shaving mirror and also used by the dentist. Okay. After reflection, the enlarged image of the teeth. Okay. The doctors can see the enlarged image of the teeth. So what I am saying is the applications of concave mirror includes torches, headlights, like that, and a shaving mirror used as a shaving mirror. The dentist use concave mirror to see large image of the teeth of the patients. Large concave mirrors used to concentrate sunlight to produce heat in the solar furnaces. It will be asked as the multiple choice question. Which type of mirror is used in or maybe question like that. Why concave mirror is used as the solar furnaces? Actually, that theory is not mentioned in textbook, but I will discuss why. Why the concave mirror is used in solar furnaces? Have you heard about this term solar furnaces anywhere? Solar furnaces. Have you heard about that term solar furnaces? No.
No, sir.
Using sunlight we can cook. Understood? We can cook items. Understood? Look like this. We have a concave mirror. Look like this. Very large. Okay, it's having very large diameter. I have a concave mirror. This side there is a coating. This side there is a coating. It is a concave mirror directed towards the sun. This concave mirror directed towards the sun. So the sun is infinite distance away from the mirror. So the rays of the sun will be coming like this. Understood? The sunlight hit the mirror like this. It is parallel to the principal axis. You know that this one is the principal axis, right? This one is the principal axis. The concave mirror should be kept like this. Okay. Just 1 minute. All of you please listen. Joshida, you are little late, but don't worry. I just started with this application. I did not explain anything. Only this thing only I discussed. So I am discussing the application of concave mirror today's class. I started with the application of concave mirror. All of you please listen. Joshida, you can ask me doubt. Don't worry. Please let me explain this. Solar furnaces. The concave mirror can be used in solar furnaces. The concave mirror look like this. The concave mirror is directed towards the sun. The concave mirror is directed towards the sun. The sunlight is coming like this. Understood? The sunlight is coming like this, parallel to the principal axis. There is a rule. There is a focus here. This is the focus of the concave mirror. We studied already. The parallel rays, first rule says that the parallel to the principal axis after reflection, it will be passing through the focus. All the parallel rays after reflection will be passing through the focus. Suppose there are thousands of, let me say like that, there are thousands of sun rays are coming. There are thousands of sun rays hitting reflected on the concave mirror. After reflection, all the rays will be meeting at the focus. So there are thousands of sunlight meeting at the focus, means that the F will be too hot. Clear? So there are plenty of sunlight after reflection meeting at the focus. That means that F will be hot point. It will be extremely hot. So so that using that temperature, we can cook the items. Understood? We can cook the items. Understood? The food can be kept here. We can easily cook it because there is a huge temperature here. There is a lot of sunlight after reflection passing through focus. So F is too hot. Using the temperature, we can cook the items. If we place the item here, it can be easily cooked. So using sunlight, we are cooking the items. Understood? Simply using the sunlight, we are cooking the item. So this is said to be solar furnaces. In solar furnace, we are using concave mirror, this type of mirror to be used. So large concave mirror are used to concentrate. We are concentrating the light at this focus. Large concave mirror are used to concentrate the sunlight to produce heat in the solar furnaces. All of you clear? Listen.
Yes.
Please respond.
Yes, sir.
Okay. So all applications I discussed. So you please write down. Joshida, before this I explained the concave mirror can be used in torches. Torches. What is the nature of the torches? The light emitted from the torch should reach a large distance. Understood? Suppose there is a tree which is at very large distance away from the torch. So the some torch contains concave mirror. Understood? Joshida, some mirror containing concave mirror. At the focus we are keeping a lamp, a small bulb is kept. There is a concave mirror, and at the focus we are keeping a small bulb. So all the light rays coming out of the focus will be reflected back, will be reflecting and going parallel. So there are powerful parallel beams emitted from the torches. This is a powerful parallel beam of light emitted from the torches. It can reach a large distance. Understood? Okay, clear? Joshida, Nishit, Samruddhi.
Yes.
Okay.
Clear.
All of you please write down. These are the applications of concave mirror. All of you please write down. If you have finished, you can raise your hand. If you have finished, you can raise your hand. Alina finished, Samruddhi, Nishit completed. Joshida, you are a little bit late, but if you have any doubt, you please ask me. Joshida. Joshida. No response. No response. So the next is only one application for convex mirror. There is only one application of convex mirror. It is used as the rear view mirror in vehicles. Rear view mirror, understood. Vehicle nearer to the door. I cannot draw the diagram. Nearer to the door. Have you seen this mirror? Nearer to the door, outside the car. Nearer to the door, there is a mirror outside to see the, understood, the car, the vehicles coming from the back side. From this, using this mirror, I can see the vehicles coming from my back side. Convex mirror are commonly used as the rear view mirrors in vehicles. So the nature of the convex mirror is we get a wider view. We get a wider view. I will show the diagram. Then you can understand. I will show the diagram. After explaining this, you can ask me doubt, okay? Look at the second diagram. Look at the second diagram. Is the second diagram a convex mirror? Yes. The first one is concave, the second diagram is concave mirror. This type of mirror used as the rear view mirror in vehicles. I mean the mirror nearer to the door. Look like this. Why this mirror is preferred? In vehicles, this type of mirror is preferred. Whatever object placed in the back side, I can view it. Whichever objects, whether it is nearer or farer, I can view from this, I mean in this mirror. I will be always getting an erect image. If I look at this mirror, I will be always see the object as the erect image. Don't use the concave mirror. When we use the concave mirror, the distant objects will be inverted. You look at the trees. Look at the trees. It is inverted. Understood? The trees are inverted. But here, no inversion take place. Whether it is objects far away or nearer, every time we will be getting an erect image. And also we get a wider view. Understood? That is required in car. Understood? When we watch, we have to see everything. So we get a wider view. That's why this type of mirror is used as the rear view mirror in vehicles. So only one application is given in textbook. No more application. Okay. So convex mirror are commonly used as the rear view mirror in vehicles. These are the reasons why we are using this. These mirrors are fitted on the sides of the vehicle, enabling the driver to see the traffic behind him to facilitate the safe driving. Convex mirrors are preferred because they always give erect image. Yes, I told you. Whether the object is nearer or far away, we will be always getting an erect image. Though diminished image, it is diminished, smaller in size, but we can see everything. We get a wider view. Also, they have a wider field of view as they are curved outwards. Thus, convex mirror enable the driver to view much larger area than would be possible with the plane mirror. Large area can be viewed. All of it clear? Only one application is given. The remaining things are the reason. The convex mirror used as the rear view mirror in vehicles. All of it clear? Understood?
Yes, sir.
Yes, sir.
So you please write down. I will come back within just 1 or 2 minutes. I will come back within 1 or 2 minutes. You please write down by till that time. Okay? Only 2 minutes maximum. The mirror is over. The next is the mirror formula problems I discussed already. The next topic is refraction of light. Remember, there's a very difficult topic, refraction of light. So far we have studied reflection of light. Understood? The reflection take place on mirror. Understood? We studied two types of mirror, concave mirror and convex mirror. The reflection take place on mirror. The refraction is a different thing. Refraction is a different thing. What do you mean by refraction? I will tell you. Look at this diagram. Why this object, what is this pencil? Pencil is bent if we view inside the, through the water, this one is appeared to be bent a little bit. What is the reason? It is due to the refraction. Okay, it is due to the refraction. I will tell you. Don't look at this diagram. I will explain. Next I am going to explain the refraction. Okay. This is due to the refraction. Understood? This is due to the refraction. So what do you mean by refraction? All of you please listen. I will tell you. I will explain step by step. All of you please listen. I have a glass. Understood? What is this? This is the glass. Or water maybe. This is the glass. Just an example. Above the glass it is simply air. Suppose a light ray is coming like this. There is a light ray incident on the boundary of air and glass. What is this? This is the boundary of the medium air and glass. After explaining this, you can ask me doubt. This highlighted portion is the boundary of the glass and air. A light is falling on the boundary of the air and glass. The incident ray is coming from air and it is going to enter the glass. It is transparent. The glass is transparent, so the reflection is too small. I mean, it can be neglected. Most of the light will be passing, crossing the glass. The reflection is there, but can be neglected. Most of the rays will be moving through the glass. Is it correct? You agree with me? Please respond.
Yes, sir.
Most of the rays will be passing through the glass, but the phenomena is there is a small bending. We expect that the light will be going like this. We expect that the ray will be going like this, but it is not happening. There is a small bending. The light rays will be, there is a small bending occur. I will show you. There is a small bending like this. The light, we assume that the light ray will be going like this, but there will be a bending. The light deviated from its actual path. This process is said to be refraction of light. So refraction means it is the bending of the light when the light passing from one medium to another medium. That's all. The definition is that much. Refraction of a light means it is bending. Understood? Let me write here. Refraction is defined as it is the bending of light when the light enter a medium, here glass, from another medium. All of you clear? The refraction is okay? Understood? It is the bending. All of you clear? Nishit, Samriddhi, Lina,
Yes,
Joshida?
sir.
Okay.
Clear.
So, there are certain important terms associated with the refraction. I will show the, okay, let me explain step by step. There is a separate diagram here, but I want to explain everything step by step. So, here there are certain important terms that let me discuss that. This ray is said to be incident ray. Understood? The first ray, I mean the ray is coming. Understood? The coming ray is said to be incident ray. And this incident ray crosses the next medium, cross into the next medium. So the second ray is said to be refracted ray. This one is said to be refracted ray. So have you understood? The first ray is said to be incident ray, and the second ray is said to be refracted ray. And remember, the next one is, let me do one thing. Let me draw a perpendicular to the medium, I mean boundary. Let me draw a perpendicular to the boundary like this. I have drawn a perpendicular, or it is said to be normal. Normal is another term representing perpendicular. Perpendicular to what? Perpendicular to this boundary. Is it correct? Making 90 degree with the boundary. So there are two important angles. The angle between incident ray and normal. Have you seen that? The angle between incident ray and normal, it is denoted by I. The neat diagram is already there. I will discuss that. But I want to explain everything step by step. The angle between refracted ray and the normal nearer to that. Angle between the refracted ray and the nearby normal. Not that one. The angle between the refracted ray and the nearby normal. It is denoted by R, angle of refraction. So these are the important terms. In exam, if they are asking for refraction, define refraction, you have to draw this diagram. Not first one. The first one is not required. It shows the bending of light. So first one is not required. This diagram is required. You have to write the definition. It is defined as the bending of light when the light enter a medium from another medium, and you must draw this diagram: incident ray, refracted ray, normal, this is I and this is R. So you understood. So let me show the good diagram here. Okay, this is enough. Okay, this is enough. This diagram is sufficient. So all of you please write down. If you have finished, please tell me. Raise your hand if you have drawn this diagram. Nishit, Samrde, understood.
Understood, sir.
Okay, all of you are okay, clear. So here there is a relation between I and R. Actually, there is a relation between I and R. To understand the relation between I and R, we must understand the important term. Let me discuss that important term. Understood? If I is given, we can easily find out R. Or if R is given, we can easily find out I. You may be thinking that I equal to R. No. I and R are not equal. If you look at the diagram, you can understand I and R are different. But there is a relation between I and R. To understand that relation, I have to introduce a new term. That is what I am going to discuss. After explaining that new term, I will come back to this diagram and I will discuss the relation between I and R. So to explain the relation between I and R, I must introduce a new term. After introducing that term, I will explain the relation between I and R. Is that okay? Clear?
Yes, sir.
So we are going, let us learn an important term to study more about refraction, relation between I and R. We must understand a new term is there, which is said to be refractive index. There is an important term associated with a medium. It is said to be refractive index. Refractive index is a fixed number. Remember, in the beginning itself I am saying you the refractive index of a medium. For example, refractive index of a glass, refractive index of a water, like that. The refractive index of a medium is a fixed number, does not change. What do you mean by refractive index? I will tell you. All of you please listen. What is the speed of light? What is the speed of light? Do you know that speed of light? You studied in the lower classes. Speed of light in air or vacuum. Vacuum or air. Have you studied it? Anybody? You studied it in 9th standard. You studied it. What is the speed of light in air or vacuum? Anybody? Samriddhi, Joshida, Lina, Nishit. Do you know that? You don't.
3 into 10 into the power of 8
Yes.
meter.
It is actually 3 lakh kilometer per second. But in physics, we don't prefer this kind of notation. We don't prefer this kind of notation. Actually, in 1 second, the light travel 3 lakh kilometer. I mean, in 1 second, the light can reach moon. Understood? The light can reach moon from Earth in simple just 1 second. So this is the speed of the light in air or vacuum. So we don't prefer this kind of notation. The speed of air is denoted by the symbol C. Please note. The speed of light in vacuum is denoted by the symbol C. The C is equal to 3 lakh is actually written as, okay, we will convert to meter also. We will convert it to meter. Just memorize this value. You just memorize this value. The speed of light in vacuum is 3 into 10 raised to 8 meter per second. So now I am going to introduce refractive index. I am going to introduce the term refractive index, which is a fixed number for a medium. Refractive index of a medium. Medium means transparent medium. Okay? Transparent medium or glass, water, like that, oil. Refractive index of a medium is defined as speed of the light through vacuum. which is 3 into 10 raised to 8, by speed of light through the medium, through the given medium, through the medium. This is the definition, okay? The refractive index of the medium is speed of the light through vacuum, which is a fixed number, divided by speed of the light through the medium. Remember, if the light is passing through the glass, its speed is much smaller than c. If the light is passing through glass or water, its speed is smaller than 3 into 10 raised to 8. So this ratio, speed of light through vacuum divided by speed of the light through the medium, is said to be the refractive index of the medium. It is a fixed number. It is a fixed number, does not change. For a given glass, refractive index is fixed. Fixed number greater than 1. It should be greater than 1 because the numerator is larger compared to denominator. Understood? The speed through vacuum is much larger compared to speed through medium. So the numerator is larger. So refractive index is a fixed number for a given medium. It is greater than 1. So for using formula, refractive index of a medium denoted by n. Refractive index of the medium denoted by the letter n is equal to speed of the light through a vacuum divided by speed of the light through medium. C by V means C stands for the numerator, V stands for the denominator. C by V. So refractive index of the medium equal to C by V. It is a fixed number for a given medium. Okay, understood. And its importance is the more refractive index, more n. N means refractive index. More n implies less speed of the light. Less speed of the light through the medium. Through the medium. Through the medium. Diamond has the maximum refractive index. What does it mean actually? Diamond has the maximum refractive index. Does it mean that the diamond is stronger? Not that. Okay, not like that. The diamond has maximum refractive index means the light through the diamond is very, very small. That's all. The more refractive index means less speed of the light through the medium. So that's why the diamond is maximum refractive index. The light through the diamond is very small. The speed of the light through the diamond is very small. Understood? So you please write down, all of you please write down, it is a fixed number, okay? If you have written, you can raise your hand. If you have written, you can raise your hand. Joshida understood, Samriddhi clear. Lina, Nishit?
Sir, clear.
Clear.
Sir.
Okay. So the refractive index will be fixed. Normally it will be given in the question. Just like understood, density, it is a fixed number, does not change. It will be given in the question. Okay. So now coming back to refraction of light. So I have explained the important terms here. So law of refraction, is it available here? 1 minute. Yes, I will write here. I will write here. This diagram is clear. Okay, the diagram is clear. Okay, the same diagram is drawn. This is the incident ray. This is the refracted ray. This is the angle of incidence denoted by the letter I. Angle of refraction denoted by R. The normal is drawn. So let me write here law of refraction. It will be asked as a theory question. Law of refraction. Let me write here, okay? Law of refraction. There are two statements. Law of refraction, there are two statements. One is, let me write the sentence. After that, you can ask me doubts. Incident ray comma normal. You can see in the diagram, and a refracted ray. Lie in the same plane. Lie in the same plane. See, in the same plane. Lie in the same plane. That is the first statement. Same plane. Lie in the same plane. What does it mean actually? What do you mean by same plane? Same plane means, for example, there is a line. Just for example, there is a line here on the screen. I have drawn a line on the screen. But another line is perpendicular. Understood? I cannot draw it. There is another line perpendicular to the screen. The line coming towards me. There is another line. Sorry. There is a one line here, and there is another line here. Okay. This line, another line, both lie on the screen. These two lines lie on the screen. But the third line, there is a third line which is perpendicular to the screen. The third line does not lie on the screen, but it is perpendicular to the screen, towards me, coming towards me. Then the three lines do not lie in a single plane. If the third line also lie in the same plane, same screen, on the screen, the third line also lie in the same screen, I can say all the three lines lie in the same plane. But two are in the plane, but third one does not lie on the screen, but it is perpendicular to the screen, the line coming towards me. Then I cannot say that the three lines lie in the same plane. So this statement says that this ray, normal, and the refracted ray. You can see three lines here. Incident ray, normal, and a refracted ray. All these three lines lie in a single screen. Understood? Lie on a single screen. Or they lie in the same plane. All of it clear? Understood? Hello? Nishit, Samarde, Joshida, understood. Then let me ask you, actually trigonometry, there is a chapter trigonometry in maths. Is it taken in your school? Let me ask you, is the trigonometry taken in your school?
No, sir.
Yes, sir.
Joshida, it is taken. Nishit, is it taken? Nishit?
No, sir. It is not taken. For
Not
us.
taken, okay. Samruddhi, is it taken? Samruddhi, Lina?
Yes, sir. It is taken.
Taken.
Yes, sir.
Okay. Nishit, it's not taken. For the time being, simply memorize this formula. There is a mathematical formula here. Don't worry, when I teach you trigonometry, there is a topic trigonometry in maths. You can understand that. For the time being, you just memorize this mathematical formula. Okay?
Okay, sir.
The formula, the second statement is sin I by sin R. Sin is a mathematical tool. I will discuss this sin later. There is no problem based on this. I will discuss it later. What is this sin? Sin I by sin R is equal to, remember one more thing. The first medium is which one? What is the first medium? The medium through which the incident ray passes. That is the first medium. This is the first medium. Okay, let us call this as the first medium. First medium has a refractive index n1. Let us denote by n1. Need not be air. Understood? The light may be passing through the water. After that, it may be entering the glass. It can happen like that. The light ray passing through water, then entering the glass, or passing through glass, then enter the water. Okay, so the first medium is need not be air. It can have any medium. So the first medium is this one. Incident ray, the medium corresponding to incident ray is said to be the first medium. The refractive index will be there. Refractive index means C by V. Memorize the formula. Refractive index is C by V. C by V. Okay, I explained already. The second medium is the medium corresponding to the refracted ray, which is said to be the second medium. It has the refractive index n2. Normally it will be given in the question, it is a fixed number. The sin I by sin r equal to n2 by n1. This is said to be, this is the second statement of law of refraction, and the second statement alone, it is a theorem actually. It is a law. The second one alone is a law actually. It is found by a mathematician, Snell. Okay, I don't know his full name. It is said to be Snell's law. The second statement alone is said to be Snell's law. Okay. So sin I by sin r equal to n2 by n1. I will discuss problem based on second one after explaining trigonometry. After trigonometry, I will discuss problem based on the second formula. So all of you please write down law of refraction. There are two statements. Please write down. If you have finished, you can raise your hand. Nishit, ആ സൈൻ അവിടെ ഇരിക്കട്ടെ, ബാക്കിയെല്ലാം ക്ലിയർ ആയല്ലോ അല്ലേ നിഷിത്? Okay, sorry, Nishit, you don't know Malayalam. I forgot. Nishit, you understood?
Yes, sir.
Okay. So don't worry about sign. It is a trigonometry. You will learn in maths. Joshida,
Okay.
Samriddhi, you understood? Samriddhi, clear?
Yes, sir.
Okay. So this is over. Now we are going to learn two special cases. Snell's law I have already discussed. Two special cases I would like to discuss. Everything is already drawn. The case 1, I don't want to redraw again. The case 1 and case 2. Refraction. There are two cases, case 1 and case 2. The first one is said to be first medium. Understood. The medium corresponding to the incident ray is said to be first medium. The medium corresponding to the refracted ray is said to be second medium. Refractive index are n1 and n2. Now, suppose the first medium is air. Just for example, first medium is air, second medium is water. If the light ray enter from air to water, you can see that it bend towards the normal. Bend towards the normal means actually this ray is supposed to move like this without any deviation. We assume that, this ray may be going like this, but that is not happening. This refracted ray bending towards the normal. Understood? What is happening to the refracted ray? It has bent towards the normal. Bending take place towards the normal. So here what happens is the first medium has a refractive index smaller than the second medium. First medium has a refractive index n1, which is smaller than the second medium. So the medium having small refractive index said to be rarer medium. The medium having lesser refractive index. The medium having the lesser refractive index is said to be rarer. The medium having a high refractive index is said to be denser. So n1 less than n2. Understood? n1 less than n2. The first medium is rarer, the second medium is denser. Then what happens to the refracted ray? Bends towards the normal. You have to memorize this diagram. Bend towards the normal. You can ask me doubt after explaining these two. Okay. So bending towards normal. Rarer to denser. Smaller refractive index to larger refractive index. The case 2. A light is coming through glass and going towards air. Understood? The incident ray passing through glass and moving towards air. In this case, we assume that the light is supposed to move like this. The light ray is supposed to move like this, but here the light ray bending away from normal. The normal is this. The light is bending away. Understood? Bending away from normal. So what is the condition here? The glass, diamond, etc. has higher refractive index. because light is too small there. The glass, diamond, water has high refractive index, means that the light speed is too small. Just telling you. So when the light n1 is denser medium, n1 is larger here. n1 first medium has high refractive index, the second medium has small refractive index. The light is entering from denser to rarer. The light is entering from denser to rarer. What happens? The refracted ray bend away from normal. So both diagram is very important. There are questions. It's very important. So I repeat. Just memorize. You must memorize. Otherwise you will forget it. One thing you have to keep in your mind is the smaller refractive index, rarer medium. The medium having smaller refractive index, rarer. The medium having high refractive index, denser. Small refractive index, lighter or rarer. High refractive index, denser. So when the light entering from rarer to denser, the light moving refracted ray move towards the normal, bend towards the normal. But in the second case, the light enter from denser to rarer. The light move away from normal. Understood? All of it clear? Okay.
Yes, sir.
So
Yes, sir.
you have to memorize this like this: rarer to denser, bend towards the normal. You have to read the sentence again and again. You will never forget it. Rarer to denser, bend towards normal. Denser to rarer, bend away. Memorize that. Okay.
Okay, sir.
So you please draw the diagram. If you have finished, you can raise your hand. Then the lens is there. In the lens you are familiar. In lens actually the refraction take place. I will explain lens, glass slab, etc. in the next classes. Okay. So today's class is clear to you. So the refraction is okay.
Yes, sir.
Refraction is okay. Two cases also okay. So let me wind up the class today. Okay.
Thank you, sir.
Okay then. Samruddhi, Lina, okay.
Thank you, sir.
Okay, bye.